Hi, in this video we're going to find a length within a pyramid. Now, the key with all these kind of Pythagoras problems in 3D is we want to identify a triangle and we then use Pythagoras theorem to find one of those lengths of that triangle. Now, where could we put a triangle here? Well, we've got this 16 here, the vertical height. Maybe if I was to put like a diagonal length like this, we can see that this triangle here, that is a right angle triangle, isn't it? Now, we know the vertical height here is 16. We want to find the length of the slanting edge of the pyramid. The slant edge of a pyramid is just basically an edge of the pyramid that goes up at an angle, at a slant. So we're trying to find this here. So this triangle is involving the 16 and it's involving the slant height that we want to find. So we would just need to first find this blue length here so we can then use Pythagoras on this yellow triangle. How do you find this blue length? Well, can you see that this blue length here is going from the corner of this base rectangle to the center of this rectangle, right? So if I draw out the rectangle separately, we can see we've got this as 12 and 10. So this is the base, just down here. This is the base, that's the rectangle. And we're trying to find this blue length here, right? Now, what we could do is that if we found the total length across the diagonal, you could just halve it to get then this blue length here, the solid blue length. So we just need to use Pythagoras to do that. Remember how Pythagoras works. If you've got a right angle triangle, you label the two shorter lengths as A and B, either way around, and the hypotenuse as C. So let's just call this, or keep it as C actually. Now, Pythagoras theorem is a squared plus b squared is equal to c squared. So let's substitute the lengths in. The a is the 10 squared. B is 12, so 12 squared equals c squared. C is what we're trying to find. Now, if we do 10 squared plus 12 squared, that's 244. So c squared is 244. And therefore, c is the square root of 244. Let's do it on my calculator. My calculator gives me 2 root 61. Now, if this total length is 2 root 61, 2 lots of root 61, then half of that from the center to here, that will be 1 lot of root 61. So therefore, this length here is, if I do it in black, this length here is root 61. It's half of 2 lots of root 61. So that's great. I now know that this blue length here is root 61. And that's great because I've got this length here is 16. This length here is root 61. And now I can find this slant edge here. Let's call that slant edge length y. I could have used x because I haven't actually used x yet, but let's call it y. And I'm going to draw out this triangle here separately. So the yellow one. So that's the yellow one I've got here. And what lengths do we know in it? We've got the root 61 at the bottom. And we've also got the height is 16. Oh, sorry, doesn't matter to do that. Height is 16. And we're trying to find y. So again, if we label the shorter edges as a and b in either order, and then the hypotenuse is c, then we've got a squared plus b squared is c squared, it's Pythagoras theorem. A is 16, so 16 squared, plus b is root 61, so it's root 61 squared is equal to c squared, which is our y squared. Now, 16 squared is, I think I know it by heart, yeah, it's 256. And root 61 squared, well, the squared cancels out the square root. So you just get 61, which is why it's useful to leave that root 61 we had earlier as a square root rather than as a decimal, because then it makes it easier to square it. And that is equal to y squared. 256 plus 61 is 317. And so if y squared is 317, you square root of 317 to get y. And that is, as a decimal, is going to be 17.8. 1 decimal place, I think it says, yeah. 17.8 to 1 decimal place. So that is the answer. That slant edge, which was y, is 17.8 centimeters to 1 decimal place. And that's the final answer.